All right, so 5-3 notes day 2 is really just a review and a recap of what we already did, just to make sure that we know what we're doing with factoring because it's such a crucial topic. So for number 1 and 2, they say factor by grouping. So remember, grouping is when we have 4 terms. So the first thing we do is we're going to group it into 2 separate binomials. We look at the first one, 3x cubed minus 2x squared, and we see what we can take out of both. And we can factor out an x squared. And what's left is 3x minus 2. In the second set of parentheses, 3x minus 2, there is nothing to take out. So when there's nothing to take out, it really is just a positive 1. At this point, we can get to our final answer, which would end up being 3x minus 2 when we factor it out from both, and then x squared plus 1. Now the x squared plus 1 is not the difference of squares because it's addition instead of subtraction. So we cannot break that down into x minus 1, x plus 1 because it is not the difference of squares. Number 2 looks a little bit more difficult just because they're bigger numbers. So the first thing that we're going to have to do is figure out what goes into 336 and 280 and so on. All right, so if you use your calculator, you could get to the point where you see that you can actually divide both of them by 56. So if you take 336 and divide by 56, you get 6. If you take 280 and divide by 56, you end up getting 5. At this point, we can look at the second set of parentheses. Those numbers can both be divided by 24. So if you factor out a 24 and a y, you're left with 144 divided by 24, which is 6y, and then 120 divided by 24, which is 5. At this point, we have 56x plus 24y and 6y plus 5. And remember, it doesn't matter what order you put those in. Now, 56 and 24 are also numbers that can be divided by the same number. So we're going to have to try to take out a GCF of those as well. The GCF of those are 8. So 56 divided by 8 gives me 7. 24 divided by 8 gives me 3. And that ends up being my final answer. You always want to check your binomials to see if you can do it a step further, such as taking out that extra 8. Okay, we could have in the very, very beginning seen that you can take out 8 from all 4, and then we would have had smaller numbers, but this way works as well. Now we're going to factor by difference of squares. So in this case, we just have to make sure that it's the difference, which means subtraction, and then everything in there needs to be a perfect square. So 4, 9, 16, and so on. And number 3, y squared and 9 are both squares. So all we have to do is square root them, so we get y and 3. And we're going to write it twice. One's a plus, one's a minus. Doesn't matter what order. If you look at number 4, 303 are not perfect squares. So we have to look at it a little different to see if we can take out a GCF first. In this case, our GCF is 3. So if we factor out a 3, we're left with 100 y squared minus x squared. Now 100 y squared and x squared are all perfect squares. So we know we have nothing out in front. Then 100, if you square root it, is 10. And we have y, and we have x. So we just have to write it twice, with one being a plus and one being a minus. Our last one, we have T-charts, which is the same thing as number sense or split middle term. Remember, you can do whichever one makes the most sense to you. We're going to look at first times last, which gives me 9. I need to multiply to 9, add to 6. And that would be 3 and 3. Remember, we put our a value and our variable in the denominator, and then we write it bottoms up. So we can write it as x plus 3, x plus 3, or if you have to say thing twice, you can write it as squared. Either answer is acceptable. Next one, you can start by just doing 6 times 60, but what I notice is that I can divide all of them by 6. So if I factor out a 6, I'm left with x squared plus 9x minus 10. And I'm going to use the t-chart with that. So first times last gives me negative 10. I need to multiply to negative 10, add to 9, would be 10 and negative 1. So when we write it bottoms up, we're going to have the 6, x plus 10, and x minus. The last 3 questions focus on solving. So that means we're going to take that extra step after we factor to tell me what x has to be. So number 7, 3 terms means we are t-charting. First times last gives me 12. I need to multiply to 12, add to negative 7. It would be negative 4 and negative 3. My 2 factors would be x minus 4 and x minus 3. If I set both of them equal to each other, I end up getting x as a positive 4 and a positive 3. On the next one, it's 2 terms, which normally is the difference of squares. But if you notice, we have a 3, we have a 4, we have a normal k. So there's not just a whole bunch of perfect squares here. So instead, let's think about it as a GCF. I can factor out a k, and I'm left with 3k minus 4. At this time, there's nothing to do factoring wise, so we just set each equal to 0. So we have k equals 0, and we have 3k minus 4 equals 0. That means my 2 answers for k would be 0 and a positive 4/3. You can rewrite positive 4/3 as 1 1/3 or 1.3 repeating. I would prefer it just as an improper fraction. Don't make it more difficult. On number 9, hopefully we notice something is a little bit different here. There is this 2 on this side, so we need to move that because in order to factor, we need it to equal 0. We would subtract 2 and rewrite our equation. 2b squared minus 15b plus 25 equals 0. Now again, we have 3 terms, so that means we are doing our t-chart. First times last is 50. To get a positive 50 and then add to negative 15, it would be negative 5 and negative 10. And we have our 2b in our denominator. Remember, if we can simplify, we should. And we can simplify the 10 and 2. They're both divisible by 2. So this is negative 5 over b. The negative 5 over 2b can't be simplified, so we just rewrite it. 2b minus 5 and b minus 5. If we solve, b is going to be 5 halves and 5.